Okay, so let's recap on thermochemistry. So chapter 2. Okay, the very first thing that we have learned in thermochemistry is the very two things that we always jumpa all the time lah. So we always jumpa exo ataupun endothermic reaction. So we have exothermic and endothermic. Okay, where exo it release heat. Okay, release heat, and endothermic it absorb heat. So absorb heat. Alright, so this are the two differences between these two reaction lah. And soalan might tanya dia punya energy profile diagram. So how can we draw dia punya energy profile diagrams? So let's see. So energy profile diagrams always have an axis lah. So it has two axes. Okay, so it has two axes. So the y-axis, right? The y-axis usually kita akan letak energy lah. Energy. Okay, but don't be surprised if some books reference book yang you tengok dia cakap it does not say energy, but it say potential energy. Okay, potential energy. Okay, so it also makes sense for the energy profile diagram to look at the potential energy lah. Okay, because kalau contoh the kayu tu you belum bakar, so it has a potential energy of how much. Bila you bakar, dia akan produce how much heat lah. Alright, so these two reaction, and we have the x-axis where we put reaction progress. Okay, so reaction progress. Okay, also setengah buku dia nak simplify kan, dia letak RXN stand for reaction progress lah. Progress. Okay, so how we draw the energy profile diagram? We always start dengan reactants. So pick a suitable place lah. Okay, kalau exothermic you boleh lah buat atas sikit. Okay, so you draw a lines, right? And you put you punya reactant. Okay, apa saja contoh that reaction, you letak dia punya reactants lah. But in this case, to simplify the diagram, saya akan letak only reactants. So reactants, right? So how the diagram will look? Exothermic, dia akan release heat. So we will have an energy barrier, and then kita akan ada dia punya product. We will get dia punya product. So product. Okay, kalau boleh buat panjang sikit ini dah terpendek lah pula. So your energy profile diagram, you have to label it up. So apa yang this hill represent? This hill will represent EA. What is EA? EA is activation energy. Okay, the minimum energy required for your reactant to become product. Okay, it has to have this amount of energy to be able untuk jadi dia punya product lah. Okay, and the differences is so the differences is delta H. Okay, and the delta H in this case of exothermic is negative value. Okay, kenapa dia negative value? Because it release heat. Alright, but your energy profile diagram is still not complete because we have here, okay, at the very top of your energy profile diagram, we have something called activated complex lah. Okay, activated complex. Okay, remember what is activated complex? Tengok balik chapter 1 where we talk about transition theory. Okay, transition state theory. Okay, same thing that we will draw for endothermic. Okay, endothermic, same thing, but now the graph will look a bit different lah, where I put a short form of reactant as R, okay, reactant, and the product is higher than the reactant, so product. Alright, okay, so this is you punya EA, activation energy. So how you want to figure out EA? EA always start dengan you punya reactants, right, to the top of the hill, okay, and then the delta H, mana satu delta H for endothermic is this, okay, the delta H, okay, the delta H is positive in value because it absorb heat, okay, absorb energy, okay, the energy of the product is higher than the energy of reactant, so it absorb heat, and we have activated complex. Activated complex. So this is exo and endothermic punya reaction lah. Okay, so now we will look on the enthalpies, which is the delta H. What is all of the delta H? You have to know this delta H, okay, so you have to know 6 and you have to remember the punya definition. Okay, so in here I just put enthalpies, but selalunya soalan akan tanya standard enthalpies lah. So we will have 1, 2, 3, 4, 5, 6. Okay, we have a lot more of enthalpies, but kita akan focus on this 6 first. Okay, nanti kat bond Haber kita akan belajar a few more lah. Kita akan belajar 3, so it will be 9 in total. Okay, so in enthalpies, apa yang pentingnya you tengok? Okay, for an example, enthalpies of formation, okay, all of this you must tengok apa yang dia nak 1 mole. Okay, so for enthalpies of formation, it says that it is the energy release, right, or energy absorbed and heat change. So here, so heat change bila 1 mole of substance, so 1 mole of substance form from its stable element, okay, from its stable element, right. Okay, so apa masuk by stable element, kita akan tengok in terms of reaction punya equation. Okay, so the important thing here, kalau for example ditanya pasal enthalpy is fine. Kalau ditanya standard enthalpies, just one more sentence that will give you the full mark lah. Elements, kalau ditanya standard enthalpies, you have to put at standard condition. Okay, that is what you need to have, right? So contoh the reaction for enthalpies of formation, contoh the formation of water, so H2O. Okay, the important thing here is you have to make sure the H2O is 1 mole. Okay, alright, so it is formed, obviously this is the product lah, the formation. Okay, so how can we buat dia punya reactants? Okay, from its stable element. So stable element, kita tengok hydrogen. So hydrogen is not stable as only hydrogen. It is stable as hydrogen gas. So hydrogen gas. Alright, and then kita tengok oxygen. Oxygen also is not stable as oxygen only. It is stable as oxygen gas. Okay, how do we know which one is stable? Okay, pernah ke korang nampak is only one oxygen? Okay, we always jumpa oxygen gas. We breathe oxygen gas. Okay, we have met hydrogen gas also. Right, So group 17, group 18, they really stable as gas. Okay, so to make sure the water is 1 mole, alright, you have to balance out the other one to make sure this is 1 mole lah. So we have 1 mole of H2O, so hydrogen is fine, it's 1 mole, right? And then oxygen, here we have 1, we have 2. So in this case, it is okay for you to put 1/2, because 2 times 1/2 will become 1, so it is balanced. Alright, so let's look on the next enthalpies. So we have enthalpies of combustion, so it is the heat release. Okay, why it is heat release? Because it makes sense, you bakar something, it will become hot lah. Right, so the heat release when 1 mole of substance, 1 mole of substance, okay, burn in excess oxygen. So excess oxygen. Okay, what does it mean by that? It means that the 1 mole that you need to keep is the substance lah. So for example, here we have carbon. Okay, kita bakar carbon as solid, and we need to make sure it is 1 mole. Okay, and it also will burn in excess oxygen. Excess oxygen. Excess. Okay, so for combustion, we always have this. Kalau dia only have carbon, okay, our product akan dapat carbon dioxide gas. Okay, period. Kalau it is carbon and then also ada hydrogen, we will also akan dapat water lah plus H2O. So in this case tak ada, so 1 mole complete and already balance it out lah. Okay, so and let's look on the atomization pula. So it is the energy required okay, is the energy required to form 1 mole of gases atom, SEOUS atom, alright, from its elements, okay. So the energy required untuk jadikan dia gas, okay, in gas form. So let's look on one example. So one example is for you to make chlorine gas. Okay, so chlorine gas, right. So for atomization, at the end of the atomization, the product should not be dual atom ataupun molecules lah. It has to be 1 atom only. Okay, because remember, chlorine gas group 17, they are stable as chlorine 2. Okay, stable like this, right? So the enthalpy of atomization said that we need to make sure this is 1 mole, right? So chlorine 2 gas kepada chlorine gas, so we have to 1/2 lah. Alright, so that is the enthalpy of atomization. Okay, let's look on the final 3. Alright, so we have neutralization. Neutralization is the heat release when 1 mole of water, okay, 1 mole of water form, okay, 1 mole of water form from neutralization reaction, okay, from neutralization process. Okay, so it means that we need to make sure it is 1 mole lah of water. So let's look on the example. So we need H2O in 1 mole. Okay, so remember, kalau for acid plus base, we always got salt. We will always get dia punya salt and water lah. So for example, let's look on the simplest one is NaCl. Okay, HCl plus NaOH. Okay, akan dapat, so HCl with NaOH akan dapat NaCl as dia punya also in aqueous lah. So we need to make sure this is 1 mole. Fortunately, everything is 1 mole lah, so it is fine. Just remember, for neutralization, we are not looking at the acid or base, we are looking at the water form. Okay, for hydration is very simple. Okay, it is the heat change. Alright, is the heat change. Is the heat change when 1 mole of gaseous ion is hydrated. Okay, when 1 mole of gaseous ions is hydrated. Okay, so what does it mean by that? Is for an example, remember it said it is ions, so it must come from ions lah. So for example, Na plus, okay, sodium plus, okay, cakap gases, okay, it come from gases ions, and it has to be 1 mole. Okay, what it means by hydrated, it just mengalami phase changes. So it changed from gases to Na plus in aqueous form. That's it. That is for hydration. Okay, so last but not least, let's look at the solution. Enthalpies of solution is the heat change. So heat change when 1 mole of substance, 1 mole of substance, okay, 1 mole of substance dissolve in water. Okay, dissolve in water. Okay, I put a short form lah. You always put water lah. So why it is very important for me to emphasize all of these enthalpies? Because soalan will tanya the definition. Okay, which one is the correct definition for the enthalpies? Okay, for an example, apa maksudnya the enthalpies of solution? You guys dah belajar in semester 1. We belajar pasal solubility constant apa semua tu. Yeah, those kind of equation yang terlibat dalam solution lah. Contoh, it is KCl is in dia punya solid form. KCl kita dissolvekan, so it becomes K plus in aqueous and chlorine minus in aqueous. Okay, and we just need to make sure that it is 1 mole of substance. Okay, so that is your enthalpies and your energy profile diagrams for exo and endothermic. Okay.